All right, so we're thinking about linear and angular speed right here. Now, it says that s is the arc length traveled by an object during time t, then the object's linear speed v is given by v equals s over t. Basically, velocity is the is s, the total distance over time. And so that should probably make sense to us now. What's important to realize is that s is the arc length, and so that is the entire length that it has rotated, and that'll make more sense when we look at some problems. Very similar here, if we're looking at the angular speed, which we do abbreviate with the omega symbol there. Well, theta is our angle of rotation. That is the total amount of rotation we have. It's not always going to be just between 0 and 360. It may have rotated a lot more than that. 0 to 360 degrees between 0 and 2 pi. It might be a lot more than just 2 pi. It may have rotated a lot more than 1. Anyways, it'll make more sense when we look at some examples. So let's take a look here. It says here, during one delivery, the tires rotate at a rate of 140 revolutions per minute. Find the angular speed of the tire in radians per minute. Well, 140 revolutions. Every one revolution around the tire, one revolution is 2 pi. So if it went 140 of these, think about that angle. That is 2 pi radians for every revolution. So 2 pi times 140, that's 280 pi radians per minute. If we change this 140 revolutions to be in radians, again, every revolution is a full 2 pi. Well, 2 pi times 140 gives us 280 pi radians. And so now we are in radians per minute. That is our angular speed. A little weird. Take a look at B. It says, on part of the trip to the next delivery, the tire turns at a constant rate of 2.5 revolutions per second. Find the linear speed of the tire in miles per hour. Okay, well, we want to find linear speed. So to find linear speed, we're going to need s, which is the arc length, and we're going to divide that by t time, and that's going to give us our linear speed. So if we're looking over here and thinking about the circumference of this tire, okay, because it did 2.5 revolutions. It did 2.5 revolutions. Well, what is the distance? What is the length of 2.5 revolutions? Well, we're going to have to find the length of one revolution first. If the diameter is 30, the circumference, which is diameter times pi, the circumference would be 30 pi inches. Now, 2.5 revolutions, here's one revolution, here's one circumference. 2.5 of these, 2.5 times 30, that's 75 pi inches. 2.5 revolutions, the entire arc length, 2.5 revolutions, that's 75 pi inches. So this was in revolutions per second. So that means, if we're thinking about this, we are currently at 75 pi inches per second. We just changed those revolutions to be in inches. We found the arc length that was corresponding to 2.5 revolutions. So we're currently in inches per second, but we want to be in miles per hour. So we're going to do some unit multipliers here to change seconds to hours. I know there's 60 seconds for every 1 minute, 60 minutes for every 1 hour. The seconds will cancel out, the minutes will cancel out. So now I'm in hours, but I need to also change inches to miles. There's 12 inches for every 1 foot, and there's 5,280 feet for every 1 mile. Inches cancel off inches, feet cancel off feet. We have to multiply across the top, divide by everything on the bottom, and we do this. 75 pi. I'm just going to go ahead and type pi in there instead of getting an exact answer. Times 60 times 60. Divided by 12, and then divided by 5,280 gives me about 13 point, I'm going to go 39. What am I in? I'm in miles per hour.